Hello everyone, I am Usharani. Welcome back to my channel. Today in this video, I am going to explain about the important concepts in the real numbers and what are the important problems. Those are already repeated in the public exams. Those I will explain. Now let us discuss about what are the concepts in the real numbers. First topic is Euclid's division algorithm or Euclid's division lemma. Both are same. Is nothing but division algorithm. So, by using that Euclid's division algorithm, you have to find out the HCF of the given numbers. That is one. And the second one, they will give you two positive numbers. Use that theorem, prime factorization method. Use that prime factorization method. You have to find out the HCF and LCM of the numbers. That is the second one. And third one is fundamental theorem of arithmetic. That fundamental theorem of arithmetic, in that you have to prove that whether the rational number is in the form of decimal or non-terminating decimal. You have to show that is it the terminating decimal or non-terminating decimal. And next one is irrational numbers. You have to prove that suppose root 2, root 3, root 5, these are all the examples of irrational numbers. You have to prove that root 2 is an irrational number or root 3 is an irrational number. Like that you have to prove that the proof is there. That is very important. And next one is in these logarithms, laws of logarithms. Now we will discuss one by one. In this first one is by using Euclid's division algorithm to find the HCF of the given numbers. Here two bits I have written. Those two already repeated in the public exams. First one is 90 and 270. Now consider first one 90 and 270. Now, in this first let us take, let A equal to big number, always you have to assume as A. So, A equal to 270 and B equal to 90. You have to consider A equal to 270 and B equal to 90. Now, by using Euclid's division lemma or algorithm, by using Euclid's division algorithm. What is Euclid's division algorithm? A equal to BQ plus R. This is Euclid's division algorithm or division algorithm. Both are same. Here A and B are two given positive numbers, are positive integers, and Q and R. Q is nothing but a quotient and R is nothing but the remainder value. These two are existing integers. Now here A we assumed as 270 big number. So you have to substitute. In place of A 270 you write. That equal to B means 90 into. So 270 equal to 90 into. In place of Q and R, which numbers you will get, that you have to find out. That means 90 is divisible in 270. How many times you have to check it. So 9 3 ja how much? 27. So 0 and 0. Directly you can write. So that means 93 ja. You leave it about the 0. I've only considered that whole number. In this natural number, whole means again including 0. Leave it about the 0. This units place 0 you have to leave it. And in the seconds place, that means in the tens place number is 9. 9 table you have to check it. 9 3 ja 27. Here 0 is there. Directly you also can write 0 in the answer. So 93 ja 270. Directly you got it. Plus that means 270 equal to 270 got it. That means remainder equal how much? 0. Till getting of remainder 0 you have to do like this. So whatever the last divisor is nothing but that is the HCF of the given numbers. Last divisor is HCF. So therefore the HCF of 270 and 90 is 90. This is the answer. Last divisor is nothing but the HCF of the given numbers. Now second one. What is that? 196 and 38,220. Now in this let us assume here A equal to, I already told that big number always we have to assume as A and second number B. So A equal to 38,220 and B equal to 196. Now by Euclid's division lemma, by Euclid's division algorithm or lemma, anyone you can write. What is Euclid's division algorithm? A equal to BQ plus R. First you write the formula. In this formula you have to substitute the given values. Where A equal to 38,220 equal, where B equal how much? 196. Now into R equal how much? S equal Q equal how much and R equal how much you have to find out. How can you find out? These are small numbers in the A bit, so directly you can write. But these are the big numbers. What you have to do in the rough column, you have to check it. How many times this 196 is divisible in this number, you have to check it. So 196, given number is 38,220. Now just you have to check it. Round out the numbers you have to consider. 196 is nearest to 200. So that means 2 after zeros, leave it. Second table you have to multiply. 2 to the 4. That means the first digit only I am considering here. 2 to the 4 means it is not there. So how many times is divisible means 1 time. Here 3 digits. Here also first 3 digits you consider. That equal to 196. Now subtract. 2 minus 6, borrow 1. So 12 minus 6 is 6. 7 minus 9, it's not possible. So again 17 minus 9, that equal to 8. And 2 minus 1 is 1. Remainder equal to 186. Now what you have to do? Next digit you have to take down. 1862. Again here I told that the big numbers, whenever big numbers are there in place of divisor, what you have to do, just you round off the number. This 196, that is a 3-digit number. This number is nearest to which hundreds number? Nearest hundreds number you have to consider. So 196 is nearest to 200. So second table you have to check it. For checking only you have to round off those numbers. Otherwise that is very difficult to here check here. So second table 2 is divisible in this how many times? 2 9 ja 18, but here 96 is just we will check it. 196 9 ja how much? As it is number you have to write down. 9 times means 2 9 ja 18, I got it. Due to that 9 I have taken. In the rough column you have to check it. 9 6 ja 54, 5 4, 9 9 ja 81, 81 plus 5 86, 8 and 6, 9 1 ja 9, 9 plus 8 17. You write 17. Yes, that number is less than this number. So you can write here 1 9. So how much we got? 1764. Now subtract. Again 2 minus 4 is not subtracted. So directly I have to borrow 12 minus 4. Directly I am writing 12 minus 4. That is 8. Here 5 is 8. 5 minus 6 is not possible. Borrow 1. 15 minus 6. 9. Here 7. 7 minus 7, 0. So what you have to do here? Directly 0 you take. Here 0 you are getting. Here also 0. So number before 0, it has no value. So no need to write zeros here. Directly you have to write down 980. Last number I have taken here. Take down. So 980. Now 196 is divisible in 980. How many times you have to check it? So I already told this number is nearest to which round of hundreds number means 200. So with the 2 you have to multiply. 2 5s are 1000. It is nearest to 1000 value. Just I will check it whether is it divisible or not. So 196 5s are 6 5s are 30. Again 9 5s are 45. 45 plus 3 48. 4 and 8. 5 1 5. 5 plus 4 9. Yes, got it exactly. 980. So 5 times you write down. That equal to 980. Now subtraction. Remainder equal to 0 we got. So here how many times is divisible? This 196 is divisible in 38,220. How many times? 195 times. This is the quotient value. 195 plus the remainder equal how much we got? 0. 196 into 195 plus 0. This problem is given 2 years back only. So many members, they are confusing to write that HCF value. Why? Because these two are nearest values. So don't confuse. Whatever the last divisor is, that last divisor is nothing but the HCF of the given number. Here, what is that last divisor? 196. So therefore, here already we got the remainder 0. Till getting of remainder 0, you have to do like this by using that Euclid's division algorithm. You have to simplify, and whatever the last division you will get, that is nothing but the HCF for the given numbers. Therefore, already we got the answer. So therefore, the HCF of 38,220 and 196 is 196. This is the answer. This is the answer. Next question is here. Show that every positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. This question. Now in this, what you have to do? Every positive odd integer is of the form 4q plus 1 or 4q plus 3. Odd integers. Odd numbers means 1, 3, 5. These are all odd numbers. So those numbers, here you have to assume that any other positive odd integer is of the form 4q plus 1 or 4q plus 3 only. You have to show like that. Now, first you have to assume that let A be, you have to assume A be, what is that? Every positive odd integer. A be every positive, A be positive odd integer. Odd integer. And B equal to how much? This form, if you observe like this, that is looking like Euclid's division algorithm. A equal to BQ plus R. Here A is the integer, that is a positive odd integer. A equal to BQ plus R, that is Euclid's division algorithm or division algorithm. So in this A be positive odd integer, you have to assume that already is given in the question. Whatever is given in the question, that you have to assume let A be positive odd integer. And B value, and B equal to how much? Here 4q plus R, that means BQ plus R. Here in place of B, whatever the number is given, that you have to assume B value, and B equal to 4. Now we apply division algorithm or Euclid's division algorithm, anyone you can write. So division algorithm for A and B equal to 4. You have to apply the division algorithm for A and B equal to 4 for those two values. Now A equal to, whenever you are applying that A and B equal to 4 value, what you will get, just you have to write. A equal to, what is that Euclid's division algorithm? A equal to BQ plus R, that is Euclid's division algorithm. So A equal to, A value is not given, that A directly have to write A, and B value is given 4. So BQ, 4Q plus R. A equal to 4Q plus R. Here that Q value, Q is nothing but a quotient and R is nothing but remainder value. The Q value is always greater than or equal to 0. Quotient value always you will get greater than or equal to 0. And here remainder value always greater than or equal to 0 and less than that B value. What is the B value here? 4. What is B? Less than 4. Whenever this condition here less than 4 only you will get, then the possible remainders are that remainder value less than 4. If R is there, R equal to 4 is there in place of remainder, then the quotient value is divisor is also 4, then 4 is divisible in 4. So here less than 4 value you have to write. Less than 4, what are the possible numbers you will get? Just you have to write R 0, 1, 2 and 3. What are the possible remainders you will get? 0, 1, 2 and 3. Now, here that is, whenever remainders you are getting, that is, A can be, that means A is the positive odd integer, that is in the form of like 4q plus 1 or 4q plus 3, you have to prove that. So, what are the possible remainders you will get? That first you have to prove here, later one by one you have to check it. That is, A can be in the form of, how you will get? That is, if A equal to, A can be in the form of, first you write, if r equal to 0, possible remainders all, here 4 possible remainders we got, one by one you have to check it, then A will be in the form of which form you will write. If r equal to 0, then A equal to, just you apply the formula, 4q plus r, in place of r you have to write 0, that means A equal to 4q. If r equal to 1, then A equal to 4q plus 1. In place of r, you write 1. If r equal to 2, then A equal to 4q plus 2. If r equal to 3, then A equal to 4q plus 3. That means remainders already we got it here. Use those remainders and substitute in the equation. Now, then A can be in the form of, how many forms is possible is there? 4q form, or 4q plus 1, or 4q plus 2, or 4q plus 3. A can be in the form of these 4. But since here A cannot be even positive, here since A value that is positive odd integer. So since A cannot be in the form of, A cannot be in the form of here 4q. That means why it is not in the form of 4q means, since A be a, I will mention here, since A be a positive odd integer. Positive odd integer. So, A cannot be in the form of 4q. Why? Because 4q can be written as 2 into 2q. That 4 is a multiple of 2. Due to that, this is not in the form of 4q or 4q plus 2. Why? Because here also, in both the terms, 2 can be written as common, 2 into 2q plus 1. Again, this term is also divisible by 2. So, A, here the condition is already given, since A be a positive odd integer. Since A be a positive odd integer. So, A cannot be in the form of 4q or 4q plus 2. Why? Because since both are divisible by 2. Both are divisible by 2. So, A cannot be in the form of like this. Hence, A can be in the form of A can be in the form of 4q. Remaining what are there? Here 4q and 4q plus 2. Those two are not the positive odd integers. So, remaining terms you have to write. 4q is not, and 4q plus 2 is also is not in the form of positive odd integer. Remaining two terms are in the form of positive odd integers. Hence, A can be in the form of 4q plus 1 and 4q plus 3. The positive odd integer is in the form of 4q plus 1. Here you can write, therefore, A is a positive odd integer. So, it can be in the form of, therefore, A is a positive odd integer. Is in the form of 4q plus 1 or 4q plus 3. This is the proof. So any doubts? Just you see, whatever the given equation is given, here the term is given. In this, you have to assume that let a be first one, a be the positive odd integer. Whatever is given in the question, that you have to assume. And b, where you have to take in terms of here q term. With the q term, whatever the constant number is given, that you have to take it as b. A and b you have. Now apply the Euclid's division algorithm. For which numbers? A and b. Whenever you are applying a and b values, then you write, hence a equal to 4q plus r. So here q value, quotient is always greater than or equal to 0 and remainder value always greater than or equal to 0 and less than 4 you will get. First you write this equation. After that, what are the possible remainders? Whenever this condition occurs, what are the possible remainders means? 0, 1, 2 and 3. Now here one by one you have to take the remainder and you have to find out the a value. If you take r equal to 0, then you will get 4q. 1 if you take 4q plus 1, like that 4q plus 2, 4q plus 3, like that you will get. That means a can be in the form of, these are all 4 forms. But here the condition is a is a positive odd integer. That is not a even positive even integer. So it is a positive odd integer. That means a be the positive odd integer, odd number. So it cannot be in the form of 4q or 4q plus 2. Why? Because these two terms are divisible by 2. Multiples of 2 means is divisible by 2. So remaining two possibilities are there, that can be in the form of 4q plus 1 or 4q plus 3. This is the answer. Proof. Next, third question here. Use Euclid's division lemma to show that the square of any positive integer is of the form 3p, 3p plus 1. This is also very important question. Already given in the public exams many times. Now how to do here? First one, you have to assume that AB. Let A be what is the square of any positive integer. Whatever the condition is given in the question, that you have to assume as A number. Let A be the square of any positive integer. Any positive integer. And b equal to how much? In this 3p and 3p plus 1. With this variable, whatever the number is given, that you have to assume as b. So, and b equal to 4. Sorry, 3. b equal to 3. First you write. A value is square of any positive integer and b equal to 3. Now, apply Euclid's division lemma. Euclid's division lemma. For which one you have to apply? For a and b values. For a and b equal to 3. First you apply. Whenever you are applying that Euclid's division algorithm or lemma for a and b values, then you will get what you will get. A equal to, therefore here a equal to bq plus r is the Euclid's division algorithm, where b equal to 3, so you will get 3q plus r. Now here is a condition here, since q is nothing but a quotient and r is nothing but remainder. That quotient value is always greater than or equal to 0. And remainder value, r value is greater than or equal to 0. Remainder always you will get greater than or equal to 0 and less than 3. Whatever the quotient is, not quotient, sorry, here divisor, that value you have to write down. Now, then the possible remainders are. Then the possible remainders are what are the possible remainders here? R equal to, what are those? Less than 3 how to write? So 0, 1, 2. 1 and 2. How many remainders you will get? Possible remainders 3. Now here, so a can be in the form of A can be, what are the possible conditions of A? Whenever remainders you are getting 0, 1 and 2, then A can be in the form of, first 0 you have to substitute in this equation, 3q plus 0, then you will get 3q, either the 3q form or here r equal to 1, then 3q plus 1 form. And another last condition is here r equal to 2. So you can write 3q plus 2. These are the possible conditions. Here, so A can be in the form of 3q or 3q plus 1 or 3q plus 2. But here what you have to do, show that this Euclid's, according to that, use that Euclid's division lemma, show that the square of any positive integer is of the form 3p and 3p plus form. 3p and 3p plus 1. So here this directly A can be in the form of like this. Now square of positive integers. That means A square equal to. A is a positive integer. Square of positive integer means you have to square on both sides. A square equal to, A equal to 3p. Then square of positive integers. That means A square equal to 3p square. Just we mention here. Square of any positive integers. Then A square equal to, first condition is 3p whole square. Sorry, not 3p. Here we got 3q whole square. Now A square equal to 3q whole square is nothing but 3 square means 9q square. 9q square. This again you have to write in terms of what you have to show that, in terms of 3 only you have to show that. So this value, entire value you have to write in terms of multiplication of 3 only you have to write down. So in this 9, 3 is divisible. So 3 into 3 is divisible in 9 3 times. 3 and remaining q square term you have to write down. 3 into 3q square. Now multiply 3 3 is 9, 9q square. Now here, since here what you have to directly, this value can be write 3p. Why? Because since I am assuming where 3q square equal to p. Here the condition is you have to show in terms of p only. Where p value we assumed as 3q square. That 3q square value equal to p. So you can write directly where a square equal to 3p. And second condition here. Second one is a square equal to, here what you got? 3q plus 1. Again squaring on both sides. Then a square equal to, this is in the form of a plus b whole square. That means a square plus b square plus 2ab. A square, that means first you write 3q whole square plus b square 1 square plus 2 into 3q into 1. This anyway you can write a square plus b square plus 2ab or a square plus 2ab plus b square. According to that, here a plus b whole square equal to a square plus b square plus 2ab. According to this formula, I expanded this term like this. Now a square equal to, just you multiply 3q whole square is nothing but 9q square plus 1 square is nothing but 1 plus 2 into 3, 6q into 1 is nothing but you will get the same number. Now again you write 9q square, just I am writing in that order, 6q standard form. I am writing in the standard form. So 9q square plus 6q plus 1. Just now. Here what you have to show that here 3q. This entire thing you have to write in the form of 3p or 3p plus 1 only. But here we got 3 terms. That is also in the form of q term. Just now you write. In both the terms 3 you can take it as common. Why? Because 3 is divisible in 9 as well as 6 also. Whenever you are taking 3 as a common, 3 is divisible in these 3 times. 3q square plus 3 is divisible in 6 2 times 2q. 1 and 2, these in those 2 terms only 3 is divisible. Just you have to take it as common. Plus 1 you write separately. Now this entire thing you have to assume as p. So here since 3q square plus 2q equal to p. Here just assume p. So this entire thing we assumed as p. Here also this entire thing I assumed as p. So 3p plus 1. Got it? So therefore, the square of any positive integer, the square of any positive integer is in the form of 3p comma 3p plus 1. This is the answer. Like this, in this one is, this is square of any positive integer. Sometimes they can ask cube of any positive integer. Whatever is there, the procedure is same. Just you have to assume as, let A be the whatever the given question. In this question, whatever the given term is, that you have to assume as A. Square of any positive integer. A be square of any positive integer. And B value you have to take is the constant number. Now apply that Euclid's division algorithm. Now in that Euclid's division algorithm, Q value, what are the possible conditions of Q and R, you have to write down. Where what are the remainders you can get, just you have to write. After getting the remainders value, possible remainders value, then A can be in the form of, just you write. How many remainders you will get, those forms you will get. Those number of forms you will get. Next you have to, square of means you have to square on both sides. If cube of any positive integer means you have to cube on both sides. Procedure is same. Right. This is the solution. Next question is, find the LCM and HCF for the following numbers by prime factorization method. What are the given numbers here? 72 and 108. Just you write down. The given numbers are integers, anything also. The given numbers are 72 and 108. Next, for 72 and 108, just you have to find out the factors by using prime factorization method. 72 is an even number, so 2 is divisible in this. 2 3 are 6. 1 is a balance, and 1 to 12. In 12, 2 is divisible 6 times. Again, this is even number, so with the 2 you should divide. 2 is divisible in 3 one time. 2 1 are 2. 1 is a balance. 1 6 16. In 16, 2 is divisible 8 times. Again, 2 is divisible in this. 2 9 are 18. But here 9 is an odd number, so you should divide by 3. 3 3 is 9. Till getting of prime number, you have to divide like this. Next, 108. Again, this is an even number. 108 is an even number. 2 is divisible in 10. In 1 it is not divisible. So consider 2 digits. First 2 digits. That is the number 10. So 2 is divisible in 10 5 times. And in 8 4 times. Next. 2 2 is 4. 1 is a balance. 1 4 14. 2 7 is 27 is an odd number. So 3 is divisible. 3 9 is 27. Again 3 3 is 9. Now, the prime factors of the prime factors of 72 equal to, so these are all numbers you write in the order. Multiplication 1 2 3. 3 times 2 is multiplied and 3 is multiplied by itself 2 times. This can be written as 1 2 3 times 2 is multiplied. That means 2 cube into 3 is multiplied 2 times. 3 square, where 72 equal 2 cube into 3 square. Again like that, 108 equal to, what are those here? 1 to 2 is multiplied by itself 2 times, right? Next 3 is multiplied by itself 3 times, into 3 into 3 into 3. That equal to 2 is multiplied 2 times, so 2 square into 3 3 times, so 3 cube. Now LCM equal to, LCM and HCF. LCM of the given numbers means, LCM means here 2 square into 3 square. What is the formula? The product of the highest power of each prime factor, prime numbers are prime factors of the numbers. The product of the highest power of each prime factor of the following number. Here what are the factors? Prime factors 2 and 3 are factor. Here also 2 and 3 are factor. What is the highest power of 2? In both 2 cube. That means 2 cube into next power is, next factor 3. 3 highest power is 3 cube into 3 cube. That equal to 2 cube is nothing but 8 into 3 cube is nothing but 27. Just you multiply and write down. 8 7 ja 56. 5 keep in mind. 8 2 ja 16. 16 plus 5 is 21. 216 is LCM. When HCF equal to the product of the smallest power of each common prime factors. Common prime factors are the following. Of the numbers. So here smallest power of the common factors in both the numbers. What are those? Here 3 and 2 both are the common factors. Here smallest power is 3 square as well as 2 square. So 2 square into 3 square. That equal to 2 square 4, 3 square 9, 9 4 36. This is the answer. This is the HCF value and LCM is this one. Next, fifth question is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 1 plus 5 are composite numbers. These two numbers are composite numbers. Explain why these two are composite numbers and how can you say that these two are composite numbers. That here you have to show here. First, write down the given numbers. What are the numbers are given? Just given numbers are these two. Just now it implies it can be written. First number is 7 into 11 into 13 plus 13. That means in this first number, how many terms are there? 2 terms. 2 terms mean that terms, how can you say? Plus or minus symbol is there in that. Then you can say that number of terms. The terms can be separated by the plus or minus symbols only. Here plus is there. So this entire thing is one term and this is the second term. In both the terms, 13 is common, so 13 can be written as common. Now, 13 is common means remaining two numbers, 7 into 11. And in the second term, 13 already we have taken it as common, so 13 1 ja 13. So you have to write here 1. And in the second term, in the second number, here this is entire thing is one term and this is the second term. In both the terms, 5 is a common number, so 5 can be written as common. So, except 5 remaining all terms you write. 7 into 6 into 4 into 3 into 2 into 1. Here again plus 5 is divisible in this one time. So, you have to write 1. That means 13 into 7 11 ja 77 and 5 into, these are all you multiply, 7 6 ja 42, 42 4 ja, just if you have any doubt, just you write down, 2 3 ja 6, 6 4 ja 24, 24 6 ja, like this sums I have to multiply. So from here to I am going 7 6 ja 42, 42 4 ja, 4 2 ja 8, 4 4 ja 16, again 3 2 ja 6, directly multiply into 6, 8 6 ja 48, 6 6 ja 36, 36 plus 4, 40, 40, 6 1 is 6, 6 plus 4, 10. That equal to 1008. 1008. So this entire number can be written in the form of 13 into one some number and second number 5 into 1008. This is in the form of, that is 13 some constant number. This is in the form of 13k and this is in the form of 5l. 1008 you can assume as L. That means these numbers are multiplied by other two numbers. That means the given number is in the form of the product of two numbers. Whenever any other given number is in the form of product of two numbers, simply you can say that those numbers are composite numbers. So 13k is k is some constant number and L is also some constant here, 1000 and L. So 13 and 5L are composite numbers. Directly you can write, therefore the given numbers are composite numbers. How can you say these are composite numbers? Means since here the given numbers are the product of, the given numbers are in the form of the product of two numbers. In the product of two numbers. So simply you can say that the two given numbers are composite numbers. How can you say? Means those numbers are in the product of two numbers. Any the number is in the form of product of two numbers, then simply you can say that those numbers are composite numbers. Here these two numbers means these two are factors. Also you can assume that 13 into 77. Numbers can be, again you can write in the form of the factors also. Simply you can say that product of any two numbers means simply those are composite numbers. This is a clarification. Next to sixth question. Write the following rational numbers in their decimal form and also write which are terminating and which have non-terminating decimals. You have to find out. First the given numbers are here 229 by 400 and second one is 8 by 225. So one by one you have to check it. First one solution here 229 by 400. 229 by 400. First you write in the decimal form. Next whether is it a terminating decimal or non-terminating decimal, you have to check it. Directly write in the decimal form means you should divide only. So 400 with 400 you divide 229. Is it terminating decimal or non-terminating? Later you can find out. Anyway you can write. Is 4 divisible in this? 400 divisible in 229? No. Why? Because it is less than that number. Take 0. Instead of that 0 you have to write here 0 point. Now 3 digits you have to consider. Here 400 is divisible in this. Just leave it the zeros and with the 4 you have to consider. Fourth table you check it. 4 5s are 20. So 5 times if you take 4 5s are 20, 2000. Next balance 290. Here 0 no need to write. Again is it divisible in this? No. One more 0 you have to take. Now again 4 5s are 20. 4 6s are 24. 4 7s are 28. 7 times 2 8 0 0. 22 zeros means directly you have to write 2 zeros. Now again subtract. Here 0 0 1. Here 0 no need to write. Here 100. Is it divisible in 100? No. Again take one more 0. 4 2s are how much? 8. Here 2 zeros means you also keep 2 zeros. 800. That means 2 times 800. Again subtract 0 0. 10 minus 8 is 2. Again is it divisible? No. One more 0 you keep. Now 4 5s are 20. So here you write 5. Here 2000. Remainder equal to 0. Whenever you will get 0 here, that is a terminating decimal. First here we found here only the decimal number. We converted that number into decimal number. 229 by 400 equal to, therefore 229 by 400 equal to 0.5729. First this is the decimal form. Next you have to check it whether is it terminating decimal or non-terminating decimal. We have the theorems. So use those theorems. You have to apply here and you have to check it whether is it terminating or non-terminating. Now how can you find out the denominator? You have to write in the form of 2 power n or 5. That means first you have to write the find out the factors of the denominator. So 400 is there. For 400 you have to find out the factor. 2 is divisible in this. 2 2s are like this. Again 2 100 times. Again 2 50 times. Again 2 25 times. Again 5 5s. You know that prime factorization method. By using this method, how to find out the factors of the given number. Just I calculated. That means that number can be 229 by 400 equal to. How can you write that 229 by 400? We found the here factors. We already calculated those factors. You write 1 2 3 4. 2 is multiplied by itself. 4 times 2 power 4 into 5 is 2 times. So into 5 square. Whenever the denominator is in the form of 2 power n or 5 power m or both 2 power n and 5 power m, then you can say that yes, it is a terminating decimal. So here two numbers are there. You can simply write yes, it is a terminating decimal. Terminating decimal. Why? Because since the denominator is in the form of, or the denominator is in the form of 2 power n and 5 power m. This is the reason. Next, second one here. 8 by 125. First you have to convert into decimal number. So with 125 you should divide 8. Is divisible in 8? Is 125 divisible in 8? No. How many zeros are required? 1 0 if you take. Is it divisible? No. So instead of this 0, here you have to write down 0 point. One more 0 is required. So instead of this 0, here you have to write 0. Now 125 is divisible in this how many times? Just you multiply here. 125, 6 is how much? Just you have to check it. 6 5 is 30, 3 keep in mind. 12 plus 3, 15, 1 keep in mind. 6 1 is 6 plus 1, 7. 125, 6 is 750. Now 0, again subtract 50. Now is it divisible? No. Take 0. 125 is divisible in 500 how many times? 2 times 250, 3 times 375, 4 times 500. 125 4 ja. Again 20, 2 keep in mind. 8 plus 2, 0, 10, 4 1 ja, 5. That means how many times here? 4 times. That equal to 4 125 ja 500. Yes, we got 0 here. Then we can understand easily, yes, it is a terminating decimal. But with the direct division, you should not say it is a terminating or non-terminating. You should not decide like that. You have to check it again here. For 125, you have to find out the factor. First, before writing that, just you write down. Therefore, 8 by 125 equal to 0.064. First you write. That is the decimal conversion. Later, for 125 factors, this is the odd number. 5 is divisible. 5 2 is 10. And 2 is the balance 25. 5 5 is 25. Again 5 5 is that 125 equal to 5 cube. How can you write? 8 by 125 equal to 8 by 5 cube. This can be written as 5 cube. Is it a terminating decimal? Yes, it is a terminating decimal. 5 25 times, again 5 5 times. So 5 cube, that means the denominator is in the form of 5 to the power of m. So simply you can say that yes, it is a terminating decimal. Why? Because the denominator is in the form of 2 power n or 5 power m or both 2 power n and 5 power m. Then you can say that simply yes, it is a terminating decimal. Yes, it is a terminating decimal. Since 125 is in the form of 5 to the power m. That is the reason. Any doubts? If you have any doubts, just ask in the comment section. Then I will give you the reply. If you like this video, please like, share and subscribe my channel. Thank you. Thank you all.